David, what is the current state of the battery recycling market?
That's a great question. It's pretty exciting, dynamic right now. I would say the if I had to pick one word, it's pretty dynamic. There's obviously a lot of interest in battery recycling industry. I think mainly because of the critical mineral supply requirements and needs that a lot of countries, a lot of companies, have going forward, especially in the lithium ion battery space. There's obviously a limited amount of supply that's out there today that people are looking at ways to recycle those materials because these materials can be reused over and over again. So there's a lot of energy excitement around, a lot of investment going on in this space. I think we're kind of playing a little catch up because a lot of batteries are being built, and there's obviously a lot of opportunity to make sure that we recover, whether it's an end of life battery or manufacturing waste that come out of these gigafactories that are being built. It's an opportunity for companies like Cirba Solutions to really, kind of catapult ourselves into the lead in the area of battery recycling.
Where are you getting the materials from? Is it somebody goes on the internet and says, "Hi, I've got a bunch of old cell phones sitting in a drawer and I'm going to send them to you"? Or do you work with the OEMs to get the big batteries or the ABBs or the Hitachis and they drop it off by the Class 8 18 wheeler? How are you getting the material?
Yeah, it's kind of a mixed bag. We get it from a lot of different sources, which is great because we're trying to increase awareness of recycling and to make sure people understand whether it's a cell phone that they have in their drawer or a laptop or an iPad or whatever it may be. That material, that device has a lot of critical materials in it that are valuable. And again, you can go like you said, all the way into the consumer space. Some of the work we do with our collection programs, we have a lot of partners out there that we work with to try to collect a lot of the consumer materials. Power tools. Now you go to a power tool store, you go to Home Depot or wherever. There's a lot of materials, a lot of devices that are using lithium ion batteries today. So that's one channel that we have to be able to collect a lot of consumer devices, and it's a decent volume. But we see the true growth of the industry is coming from electric vehicles, right? So as electric vehicle penetration continues to rise in North America and more electric vehicles are on the road, they eventually will reach their end of life. And at the same time, those batteries reach the end of life, you have a lot of batteries being built in North America, right? So I think we say by 2030, there's going to be over 900 gigawatt hours of battery capacity operating in North America. Right now, we're at 150, I think, somewhere around 152, 153 gigawatt hours. So that's a pretty substantial increase, a 7x increase almost of what capacity is going to be coming online. And every one of those gigafactories produces waste material. We call it battery manufacturing scrap. When you make a battery, there's lots of parts of the process to make a battery, and there's waste material in there that can be recovered, whether it's the electrode that has precious materials on it, like lithium, nickel, cobalt, or the aluminum and copper that are used in a battery. So all that waste material that's being generated as the batteries produce is another feedstock for us. So people like to think of a battery, that's what we're recycling. We are recycling a lot of batteries. You mentioned OEMs, a lot of car companies out there have batteries that either are end of life. There's obviously recalls and defective batteries that we deal with on a daily basis. And then you have things like, there's accidents and there's defective batteries and things like that we take care of. So the source of our material is very, very broad in terms of where we get these things. But it's amazing because this industry is growing so fast and the amount of capacity out there that we're planning on building to meet that market demand is pretty substantial.
With 750 gigawatts planned to come online, is there enough capacity from a recycling perspective to meet that demand?
No, not real. Not today. Not today. Look at a gigafactory will produce, a good gigafactory operates at around 10% scrap rate. So 90% of the batteries are good, 10% of the batteries or the material that are being used to make a battery end up being scrap. And a lot of people think, I'm a chemical engineer by training, so I think that's crazy to have that much waste. But when you think about a battery and a battery pack that has to be built for your vehicle, there's lots of battery cells, right, that go into a battery pack. And every one of those has to be perfect, right? If it's not perfect, you have a problem. And no one wants to have a problem with their battery, right? No one, whether it's your consumer devices or especially your vehicle, you don't want to have a bad battery. So the scrap rate is there to really protect the consumer and make sure that every battery that comes off there, they're as confident as they possibly can be that it's going to be perfect, it's going to perform. So those scrap rates, so if you take that, right, and you say, let's say it's 10% scrap rate, so that's 75, let's say it's with all the capacity, 90 gigawatt hours of battery capacity that's scrap, right? So 10% of that 900 that I mentioned. The gigafactory out in Nevada that everybody talks about is about a 35 gigawatt hour battery plant. So you can imagine almost three of those battery plants are just going to be making scrap all the time. Now they're from a perspective of total volume. So it's a significant amount of volume that is coming online as manufacturing scrap. Not to mention, look, the EV batteries have been on the road since 2010, 12, 13 time. There's a lot of vehicles out there. We're seeing some of those come off the road today. And we're fortunate enough to have those batteries going through our facility and processing them.
You brought up a very valid point, which is not talked enough about, is quality control. I have an EV. It was deemed a lemon by the manufacturer. So obviously, somehow it failed quality control, but it still got to me. That battery hopefully will end up with your company or end up in another company to be recycled. When you recycle and you extract the materials and the metals, how do you ensure quality control?
Now, that's a great question. And I think when you look at all the way back to the materials themselves, so whether it's the lithium, the nickel, the cobalt, the manganese, right? We have something called the battery grade specification that we have to meet. So the industry has specifications out there for the raw materials, be able to meet a certain level of quality. And really, there's things like particle size distribution and moisture, but the main component that really is looked at are the purity levels, right? So things like iron, things like calcium, manganese, or not manganese, calcium and sodium. Those are things that typically can inhibit the performance of a cathode material of a battery. Iron is obviously really, really bad, right? You don't want iron in a cathode because it could short your battery out. So that's really not something that anybody wants to have happen. So, we have very tight specifications in our materials that we produce. So the process that we use to do that is very tight quality control. It's almost kind of clean room environment. And if you go into a battery gigafactory, you kind of see a clean room type environment, and especially in the material preparation and the formation of a battery. When you're putting a pack together and you're putting cells together, it's not quite as clean room. I mean, there are a lot of requirements there from obviously quality control. It's really, I would say, specialty chemical clean room type environment that's required.
To meet the battery grade specifications, is that a standard set by an NGO or standards body organization, or is that something that your company has developed independently?
It's standards set by our customers typically, right? So they know the quality specifications that they can live with to produce a good material, right? Good cathode material or a good battery. And that kind of flows down across to all the material providers. So if you even look at just the substrate of the foil where a cathode or an anode goes onto, like the aluminum or copper foil, there's quality requirements for that aluminum and copper as well. That it has to be a certain purity level because they're looking at those quality requirements. Over the last 15 plus years, they've done a tremendous amount of studies, understanding what those tolerances are in terms of raw materials, in terms of impurities that they can accept. They would love it to be zero, right? 0.00000, but that's really, really challenging to get to and costly. So they've kind of got very tight tolerances on the impurity levels that we can achieve, that we can deliver to them, and then they go into their battery.
How does battery recycling get more efficient from a chemistry perspective? Is it newer technologies? Is it new chemistry breakthroughs? How do you increase that efficiency?
Yeah, there's a number of ways. The battery chemistry has evolved over time, right? You hear a lot of different cathode chemistries being mentioned, like high nickel NMC chemistries, or LFP, which is lithium iron phosphate. NMC stands for nickel, manganese, cobalt. So they're the different cathode formulations that people talk about today. What the cell manufacturers and OEMs are trying to do, right? They're trying to maximize range or energy density. So more energy density you get into a battery, the more range your vehicle can have. They're also trying to ensure that they've got a safe battery, right? First and foremost. So there's some safety requirements that they have in terms of materials. And then also cycle life, right? You want the battery to last as long as possible. You don't want to replace it every 5 years or 10 years, even in some cases, right? So they're trying to improve the quality of those battery and the chemistry there. So when we look at those advancements, we also are trying to develop our technology to make sure that we're able to process at a very high efficiency all those different cathode chemistries and battery chemistries. The goal for us is to recover as much material as possible. So we say we have 95% recoveries. So when we look at the nickel, the cobalt, manganese, things like that, we're basically committing to recovering over 95% of that material. I would love to say that we can recover over 98%. You get above 98%, you're getting into some really tight standard deviations of being able to do that. So the technology that we're really working on is focused on the impurity removals. It's focused on the efficiency of extraction. So we don't want to lose any of those metals as we process the batteries.
How much of the recycling process is automated today, and how much of it do you expect to be automated in the future?
That's a really it's a fascinating question, something that we talk about internally a lot. We if you look at the industry today, it's fairly new, right? So the lithium ion space, especially recycling large battery packs from an electric vehicle, is fairly new, right? A lot of batteries that haven't come off the road yet. So you're getting a large battery pack in that, you at some point have to disassemble, take the modules out. You want to recover the steel and the aluminum separately, the copper harnesses that are on a battery pack to actually do, to run the electronics. And then you come down to a module. So if you can imagine, we get a 1,000 pound battery pack in from an OEM vehicle, and we have to disassemble that battery pack. Today, a lot of that is very manual, right? So we have a lot of work instructions on how to do that safely, because some of the packs come fully charged, right? You have to be careful, and some of them come completely discharged. So we've got a wide range of safety precautions that we take as we process these materials. But as battery cell design and battery pack design continues to evolve, we've got to relearn how to take those battery packs apart, right? So I think automation is going to rapidly increase here in the future, but it's hard to automate when things are changing all the time. You have machine learning out there. We're working with some companies that do a lot of machine learning with robots on how to take battery packs apart and things like that. So we're continuing to do that. But I think over time, that will evolve to would that be a much more automated process. Our process, once the battery's been disassembled and we are shredding the battery and extracting those metals, we're anticipating a fairly highly automated type system. We're going to have operators in the plant. We're going to, manage how the process is operating, things like that. But the goal is to minimize exposure to having a lot of labor around the plant, right? I mean, in the end of the day, we want to make sure it's as automated as possible so we can recover as much material as we possibly can.
I'm fascinated now. You just stepped into it, which is great because now I'm going to ask curiosity questions. When a battery comes fully charged, how do you do it without, I'm going to pull a Fred Flintstone without going kablooey? How do you do that?
Yeah. There are ways to do discharge. And look, we have to evaluate, like we're in the end of the day, we're not a nonprofit, right? We have to make money. And every step that you take in processing a battery comes a cost, right? So we look at what's the cost of discharging, reusing some of that energy if that's possible. What's the cost of processing that material and having a system that's able to handle that thermal kind of potential that battery has. And today, our existing process has looked at really, we're going to handle that full event if there is one through our process safety. And we've got a system that's designed to basically manage that. We got some submerged systems where batteries basically underwater, and it doesn't have to have any, there's no real thermal event that the water can't handle, right? So we've designed it to take care of that energy that potentially is released from that battery. Right now, we've looked at designing a system in place to be able to manage whatever thermal activity a battery could or couldn't have. In the future, we obviously will look at, is there an economical way to do more battery discharge? It's really tough today. I'll be honest with you. It's really tough to, you say, well, hey, it's free energy. You should be able to do that. Well, you got to build a battery storage system to do that, right? And battery storage systems, guess what? Not free. They cost money. And then you got to figure out how to, link that up with your entire site. So there's all kinds of not only technical things, but still economical aspects that we look at how we operate our facility.
It's called the dream vision outside of economics. It's complicated, and there's a lot that's going to go into that. And sitting here running math in my head, if I'm in your shoes, I agree with you. I can't make an economic argument to rebut you on why you should do that. When the batteries come in, how do you know if they're decharged or charged or what the current state is? How do you know that? And how do you verify that?
Yeah, so we've got some highly trained, technicians that work at our company, and they validate that. So they know a battery comes in. Sometimes the OEM will tell us like, hey, this is state of charge, or it was a damaged battery potential. Like sometimes we get batteries that come in and they're damaged. Those are typically packaged in a special way because you can't just throw a battery in the back of a truck and drive it down the road. You've got some regulations you've got to follow to be able to do that. And we help our customers, particularly with packaging. So, we like to start with our customer engagement that we have with them on the front end of what are we getting from you, right? Are these batteries charged? Are they discharged? Are they just waste electrodes, whatever it may be? And if we don't know that, then we have a system in place that actually can hook into a battery and tell you what the state of charge of that battery is before we process it. So we're prepared with our systems and processes and safety requirements to be able to manage that.
Are there limitations to either the size or chemistry of the batteries that you're able to recycle?
No, I mean, today we're processing some very large batteries, and the expansion project that we have going on right now in Lancaster, Ohio, same thing. We're designing it to handle large batteries, whether it comes from a semi, comes from an industrial vehicle, or from an electric vehicle, a car, right? A light duty vehicle, whatever that may be. So we've kind of designed it knowing that in the future, we think the battery packs are going to get bigger, especially as you go into different market areas, right? So we're getting companies that are using heavy equipment, Caterpillar and companies like that. They're using heavy equipment. They're thinking about switching to lithium because a better carbon footprint. Two, they don't want to deal with diesel and things like that. That's not a good thing from an ESG perspective. So they're looking at lithium-ion battery technology, and these are very large batteries. Same with energy storage. A lot of these energy storage banks are storing solar and wind energy. They're typically fairly large battery systems that are coming into our facility that we have to recycle. So we've designed that flexibility in our processes to be able to handle any type and size battery. We run everything from a cell phone to a battery pack out of an EV.
What's the first thing that happens when a shipment arrives of batteries to be recycled?
Yeah, so typically, again, quality control, we scan whatever we have coming in so we know exactly what material we have coming into our facility. We do a safety check. Obviously, we want to make sure that that battery has arrived in safe condition because batteries are being transported across the road. There could be some damage that occurs as the battery is being transported. Our trucks that we have from our logistics fleet are equipped with, we've got very qualified drivers that are trained to handle these materials and drive these materials across the road. But we also have trucks that are equipped to manage any thermal event that could potentially occur. But really, it comes with a quality check as that material comes in. We scan the material, we look sure there's no issues, and we constantly do that with any battery packs that we have in our possession. And then we put it in our system, and basically we've got a process then that we look at how we actually process material. And we do a lot of mixing of different battery chemistries because we're trying to look at the optimal blend of nickel and cobalt that could come out of those batteries. A lot of consumer devices are LCO, so they're lithium cobalt oxide batteries, no nickel or manganese, or there are a lot of cobalt. So, we want to understand the chemistry that we have running through our facility so we can also optimize the extraction efficiency that we have downstream. So it's really bringing those batteries in, understanding what chemistry we potentially have, and what does the battery look like from a health perspective.
What impact does the price of lithium have on the flows that you're seeing in battery recycling? Was it 2 years ago we had that massive run up in lithium, and then recycling was all the craze, and the lithium price slowed down, and now platinum's taking off. What impact does the price of lithium have on the business?
Yeah, look, it's great when lithium is high, right? I mean, we extract lithium as well. So the fact that we can extract that material effectively and make sure that it gets back into the supply chain, whatever we extract is important for us to be able to extract as much value as we can out of that because it's part of our process that we use to purify that lithium metal or that lithium component that's got there into a lithium salt again that can be reused. So it's definitely important, but we also have other highly valuable materials in the nickel and cobalt that really today drive the value of lithium ion battery recycling, partly because there's a higher concentration of those metals in a lithium ion battery than there is lithium. So when you look at it from a mass balance perspective, the nickel and the cobalt value is higher than lithium value. But look, when lithium's at $70 a kilogram, that's a good thing, right? Everybody likes that, and the value of lithium is really high. So we watch it closely. We kick money whether lithium's at $12 like it is today or it's at $80. We're very confident with our processing capability and the outlet that we have for those materials to be profitable.
Taking any of this to Chicago Merc and trading it on the commodities market, is that part of your business, or you're just a pure recycling business?
We do. I mean, we look at the LME, right? So if you look at nickel and cobalt, manganese as well, aluminum, copper, they're all traded on the LME. So that's usually the benchmark that we're using. Our customers, obviously, they want to have some sort of benchmark that they can use to price their material or understand what value we're extracting for them. So we do use the London Metal Exchange to be able to look at metal pricing a lot. Our contracts are kind of tied to that. And that's on the front end of bringing batteries in and what the value of those batteries could be. Sometimes we have to pay for batteries, sometimes we don't. It just depends on the consumer and where that material is coming from. And then on the back end, right, we want to make sure we extract as much value because we've had to put a lot of time, energy, money in processing that battery, purifying that metal again, and extracting it for the consumer to use. So we're obviously pricing in what the representative value of those metals is on the back end of our process as well.
You're following the LME, you're following commodities. The next part that goes along with this is weather, because that has a large impact. Are you following weather? And then, unfortunately, a lot of these materials come from sub-Saharan Africa and in it's called political hotspots, is what I'll use that word. Do you have a team of individuals that are just following all those things because it can have a direct material impact on your business?
We do. I mean, that's the overall. You step back and look at our business, right? The end game for us is to create a closed loop supply chain, right? So when you look at the overall supply demand balance across the world, like you said, it depends on what happens. I mean, if there's a massive rain event in the Atacama in Chile, that creates some problems for those producers, right? Producing lithium. Or if there's any, issues in Indonesia on nickel mining, right? That creates an issue for nickel supply, right? So there's lots of things that go on. Russia, that you throw Russia in there, that creates a lot of challenges as well, right? So we watch all of those dynamics going on, because what it does is it impacts the overall supply and demand balance in the industry. Now, I think it's important, but I also step back and say, well, look, in the end of the day, if we're not recycling and recovering these metals, shame on us, because it's a material that's already been extracted out of the earth. There's been a lot of time, energy, and money that's been put into that process to be able to extract those materials. And it's our duty and our responsibility to make sure that stuff doesn't end up back in a landfill, right? So recycled content, it kind of feeds back to your first question. What's the recycle market look like? Everybody's very excited about the recycle market. One, because it's recycled content. There's also some incentives for companies, obviously, with the IRA to use recycled content in their batteries. But also they look at it as, look, if I can close loop this here in North America, I don't have to worry about what's going on in Africa. I don't have to worry about what's going on in Australia, right? I've got access to these materials and they're staying in North America. So having as much recycled content for us as a business is a very positive thing for us. And it's important. And that's why we're building that supply chain out, to try to close that loop.
It's positive for the environment. It's positive for geopolitical stability. It's positive for a lot of economic reasons. I'm curious, what type of degradation happens as the batteries get recycled? And do we get to a point where a battery can only be recycled so many times to where it has to be put out to pasture?
Yeah. No, I mean, that's the nice thing, right? Lithium, nickel, manganese, cobalt, they don't evaporate, right? They don't just degrade to where you can't recover them. So those metals, as a battery degrades, it's not the lithium that's degrading. It's actually, or the nickel or cobalt that's degrading. It's actually a bunch of other chemistry that's going on in a battery that's preventing that battery from charging and discharging as much energy as it possibly can. So there's, like they call them dendrites. I won't get into the details about it, but you're basically preventing that lithium molecule from transferring back and forth, store and discharge energy, right? It's kind of being bound up into another form chemically. Well, when we recycle that, we release that lithium back again, or we release that nickel and cobalt back again to its original form. So that's the nice thing about recycling in these metals, is they can be reused over and over again. I mean, they can be reused thousands of times. The only challenge you have is, how do we be more efficient, right? How do we, instead of 95% recovery, how do we recover 98 or 99%? And that's what we're working towards. But these metals don't evaporate. They don't change their physical state. You can recover them and get them back to their original elemental state through our process.
Everybody talks about recycling for cars, but I'm going to put my curiosity hat on again. There was an announcement today from Robert Bosch, the large tier one automotive supplier. They bought an HVAC company, and they're now going into home automation. Obviously, they make washers and dryers and all sorts of household appliances. Well, there's batteries in those. Do you see recycled batteries going into household appliances, then to cameras, to computers, all sorts of, even lights, for example? Do you see it going to a wide variety of use cases instead of just this general talk around cars? Because there seems there's so many use cases outside of vehicles.
There are a lot of use cases, and a lot of them you see on the fringes right now, whether it's, drones. I mean, a lot of people, obviously drones have lithium ion batteries in them, or, things like even aircraft, right? There's a lot of discussion around aircraft, but can that eventually electrify as well, right? So there's a lot of ancillary applications that you're seeing out there. We get a lot of devices that come through our facility every day. And I, every time I walk through, there's something new. I'm like, I never thought that would have had a battery in it, right? Especially a lithium ion battery in it. So it's just amazing to see, whether it's children's toys or, all kinds of things. Everything today has like a battery in it. Your headphones you're wearing right now, they have batteries in them. There's lithium ion batteries out there, right? That's why they can work without a cable. So there's a lot of ancillary type of, piece of equipment. I think, home electronics is an area that's definitely coming. The HVAC stuff would be interesting to see. I mean, I think there's probably some parallels with like home storage where those systems are going to be linked up with home battery storage. I think that's an untapped market. I do think we call it kind of grid storage or energy storage. But if you look at wind and solar, like there's a ton of wind and solar that's being put in place today in the market, and that energy has to go somewhere, right? As it's generated. And typically, but they try to put obviously as much as they can into the grid to overcome, some of the peaks and blackouts and things like that. But a lot of it is going into these massive energy storage systems, which typically are lithium-ion batteries, because then you can store that material or store that energy, and overnight when it's not sunny out, right, you can discharge it back into the system. So there's this cycle that really makes sense from an energy storage perspective, where I think lithium-ion is going to continue to play a role.
Then there's data centers. Data centers are getting backed up by nat gas, they're getting backed up by batteries. Could you see one of your customers potentially placing a large order for your recycled material to put it for battery backup for a data center?
Absolutely. And we talked to a number of companies that have massive data storage centers. They could be telecommunication companies, they could be internet companies that are out there that have these massive data centers. Like you said, they're depending on, they don't want to shut down, right? So they've got battery backup systems that one can avoid any glitches, right? They don't want to glitch either, like a quick flicker. They don't like that either because that shuts things down and messes people's data up, either uploads or downloads up. So there's systems there that we obviously are working with those companies, one, to make sure that we recycle those used batteries when they're reached end of life, but also work with their supply chain to make sure that those materials that we're recycling from them get put back into a new battery that goes back to them, right? So that's kind of the whole closed loop system. If you think about it, it makes sense from like an automobile OEM, right? They want to have control as much as they can of the materials that they're using in their vehicles. So when they talk with us, like, look, we'll give you these batteries, but we want you to, when you recover those materials, can you work with our cathode producer or our cell manufacturer, for example, that's building these batteries and make sure that material goes back to them. So we're truly creating that closed loop ecosystem for the automotive industry for sure.
So hypothetical, let's just say Acme Automotive approaches you and says, okay, David, we're going to give you, let's just do simple math. We're going to give you 10 electric vehicles for you to do. You get it, you extract it, and then it goes back into the field, say 7 years. 7 years later, you get those 10 batteries back and recycle it. You just keep going over and over again.
That's the plan. That's the plan. We want to be an integrated supplier with the cell manufacturers that are making batteries, because like I mentioned earlier, there's manufacturing waste there that we can recover for them and again try to help lower their cost of making a battery. But the same thing is with an OEM. We want to be part of their critical supply chain that they have in producing an electric vehicle, which part of that is how do they use recycled content to make a new battery and just keep recovering those batteries and those materials over and over again.
Do you feel that recycled batteries can potentially lower the price of EVs today?
I do. I think so. I actually, well, I know it does. We've done some studies where, if you look at even just the carbon footprint ends up into dollars as well, right? We look at carbon footprint. So, getting your material from our plant in Lancaster, Ohio, sending it to Michigan or wherever, Georgia, to build a battery is a lot better than having to source it in Australia, right? Or source it in Chile, right? So you've got logistics costs that you're lowering dramatically. You've got, again, there's a cost to carbon, right? So the CO2 footprint that you're reducing by doing that. I mean, we can reduce the carbon footprint of nickel by more than 40%. Lithium, probably even more because of the way lithium travels today. So you look at that carbon footprint reduction, that's an economic savings for a company as well, especially as they try to become net zero someday in their carbon footprint strategy. So those are things that we know help lower the cost just from a pure logistics perspective, as well as, the cost of mining is going to continue to increase because it's harder and harder to find cost-effective sources for these materials, right? And the fact that we've already got it out of the ground, it's just sitting in a battery. Now, there's a lot of hard work and energy that goes into making sure that material becomes purified again, but it's a lot easier than trying to find a mine somewhere, typically in very challenging regions of the world, and there's a cost associated with doing that.
You said something that's only been highlighted in weird, wonky financial circles that I run in. The cost of carbon. I was fortunate. I saw a map of looking at lithium and where it goes from the ground to the refining and all the ships and the different routes. And then same thing with cobalt, all those critical mines. They're long journeys. If you want to put it in airplane talks, you're on a 20+ hour flight without layovers. And these ships produce a massive amount of carbon. Maritime is getting interesting because you're seeing hydrogen go into maritime. You're seeing battery technology go into maritime. When we look to the future, do you see maritime potentially being one of your largest suppliers of batteries is because the growing demand to electrify and reduce carbon in maritime, especially from a large commercial shipping application?
I think that is an option, right? I mean, if you look at the scale of, again, it comes down to the distance of these where these ships have to travel, right? Can the battery energy density match that of what they're using today, whether it's hydrogen or diesel or whatever type of fuel system they're using in those ships? But I do think there is an option there. I mean, lithium ion batteries are going to continue to get more and more efficient. I think you fast forward, 5 years or so, and you look at solid state batteries, which you've heard a lot about that, I'm sure. The energy density on a solid state battery, you're more than doubling, almost tripling the energy density of a battery in the same volume of volumetric space that you're using. So when you start to take those economics and you apply it to large applications, whether it's fleet vehicles on the road or maritime vehicles on the sea. I mean, those economics start to really look attractive, I think, to companies. And again, it's not only the cost of using fuel and things like that. It's also just the carbon footprint of that, right? I mean, we've done the study like 50,000 miles is kind of distance of a lithium molecule. If it's mined in Chile, by the time it gets refined, turned into a cathode, and put to a battery plant in North America, it's like 50,000 miles. That's quite a distance, right? Versus, coming from our plant in Lancaster, Ohio could be, 100 miles, 200 miles.
Solid states, they're the future. They're coming. We've all seen and read the Breakthroughs Nature magazine. Says some really interesting from a scientific standpoint on the write ups there. From a recycling standpoint, will you recycle a solid state battery differently than you recycle a lithium ion battery today that's not solid state?
There'll be a little, I mean, not a lot. To be honest with you, we actually are recycling some solid state batteries today because there's obviously manufacturing solid state batteries out in the industry. So we do take some of the waste material as they test these new batteries out. And we run through our same process. The unique thing about a solid state battery and the nice thing about it is it doesn't, well, if it's a true full solid state battery, it doesn't have a flammable electrolyte in it, right? So the thermal profile of that battery is much, much easier. What it does has more lithium, right? So we make sure that our lithium circuit to recover that lithium is actually tailored to be able to handle that, because in many cases, a solid state battery has a lithium metal anode, right? So you've got your cathode is basically the same. You got a polymeric or ceramic separator electrolyte system, and then you've got a lithium metal anode. In lithium metal, we process lithium metal a little bit differently than we would process just a normal cathode material out of a lithium ion battery. So we've kind of looked at how that system works, and what we think that we've got a process now that we basically can enhance what we're doing today that still will enable us to process those solid state batteries. We're doing it, like I said, on a small scale today, but as that scale grows, we're going to adapt our system to be able to handle a larger volume of solid state batteries in the future.
Do you feel that solid state batteries eventually in the future could be your largest volume of business?
I think if it's adopted in the automotive space, absolutely. I think if you get to a point where a solid state battery makes it into the automotive industry and you start seeing the auto OEMs, which a lot of them are talking about it today, right? Studying that today, I could see solid state batteries definitely being there. And, the nice thing about that for us is the value of those batteries are higher, right? The value of that solid state battery is going to be higher. You're going to have more lithium to recover in there, which is great for our perspective. And then you still have the nickel, manganese, and cobalt in there that recover. You don't have the flammability issues, the solvent issues. So in some respects, it would be, nicer for us to actually process more solid state batteries.
All right, so here's a cheers to solid state batteries. Scientists keep building. In your opinion, what is the future of the battery recycling business?
I think it's going to be, I think a couple things. If you step back and look at where this industry is today, we're on this massive growth curve right now of, starting it if you look at electric vehicles, right? We're in this cusp of electric vehicle growth. The penetration rate is still, in the high single digits, low double digit range, right? That can definitely grow. And if you see that growing into 30-40% in the next, 10 years, that's a massive opportunity for battery recycling. Because I think what's good about this is the automotive industry understands the value of those metals, right? They know the limitations of supply that are out there today. So we've kind of we've got a customer that's already bought into, we want to recycle, and we need a partner like Cirba Solutions to do that. I think one of the things that we want to continue to do on the consumer side is make it easier for consumers to recycle batteries. Right. Every time I talk to someone, they're like, I don't know what to do with my old cell phone. right? I don't know what to do with my old laptop. I don't know what to do with my iPad. So what we're trying to do at Cirba Solutions is create opportunities, and you can go out to our website, serbasolutions.com, and there's opportunities for you to recycle your batteries out there. We've got kits you can buy, and it will show that those batteries, get sent to our facility and processed safely. But we're trying to increase that awareness from consumer because if people are aware that they can recycle their cell phones, they're going to think also about their car battery, right? And if they go to an electric vehicle, that's going to be in their mind. Oh, hey, I've got to. I also think it increase the penetration rate because a lot of people that I talk to, like, I got an EV, but I didn't even think about what's going to happen with the battery at the end. And if we can tell them, hey, that battery is going to be recycled, those materials are very valuable. They're going to be recovered over and over again. A lot of people like that story, right? That buys into why they also bought an EV. Some people don't care. That's fine. They just want to drive a really cool vehicle, and EVs are great to drive. So I think we've got an opportunity though to educate people about that closed loop supply chain that we're trying to create.
When you make it easy to recycle a battery, you get rid of one less junk drawer in your house or a junk closet because the stuff. I can't tell you how many times in multiple houses I've had that old laptops, iPads, it just piles up there along with all the cables and the dongles that never work and they're incompatible as we go forward. So recycle your batteries. It's good for your house. Your wife will probably appreciate it because you're going to get more storage back. David, this has been really, really insightful. Thank you for coming on today and sharing your expertise in battery recycling and lithium. As we look to wrap up for today, what would you like our listeners and viewers to take away with them?
Yeah, just a couple quick things. I mean, we talked a lot about the industry. I think Cirba Solutions, in my mind, we're the most comprehensive battery materials and management company out there. We've got over 30 years of experience of recycling all different types of battery chemistries, with obviously our growth focus on the lithium ion space. One of the things that I always try to tell people is, the largest operating mine in the world today is driving on a road with electric vehicles. And it's Cirba Solutions is being built and has had the focus over the last few years to make sure that those materials don't end up back in a landfill and that we recover those things safely and make sure that they go in a new battery and we can continue to make EVs, consumer devices, cost effective for everybody to have access to in the future. It's a great industry right now. We're in this cusp, like I said, we're the start of that growth curve. So we're really focused about bringing really good people to our company and make sure that we provide closed loop option for the United States and for those critical minerals.
Partner with Cirba Solutions. Help to usher in the circular economy. The future is bright. The future is autonomous. The future is battery recycling. David, thank you so much for coming on the road to autonomy today.
Great. Thanks, Grayson. I appreciate it.